Hello everyone. So in this video, we will learn how we can find a proportion given a z-score. We will learn how to find a z-score given the proportion. Also, we will work on with non-standard normal distribution, finding the proportion given a z-score or given the z-score finding the proportion. We will also learn how can we find a t-score in R. And lastly, we will work on the QQ plot. So if we can using QQ plot, we can check whether a given variable or a given data set is normal or not. So first of all, let me share the screen with you all and open Art Studio. Okay. So just like before, I will open a new file and a new art script. Now, for the first thing I want to do is I want to find the proportion given z-score. That is, the z-score is given to you, you have to find the proportion. For example, we have to find a probability that z is less than 1.2. How can we find this kind of a probability or this kind of a proportion in R? To find this, we will use the pnorm function. So if you have this pnorm function, it asks for the q, it asks for the mean, the standard deviation, and whether the lower tail is true or false. So pnorm, for this case, q is the quartile that I'm looking for, that is 1.2. This is, we are looking for z less than 1.2. Z is a standard normal distribution that implies that it has a mean of 0. So we have the mean to be 0, and the standard deviation is always 1 for a z distribution or for a standard normal distribution. And over here, since we have, in this case, we have z is less than, so that's why we should have the lower dot tail. This should be true. Now, lower dot tail equal to true, this is by default, so you can write this or you can omit the last part. So if you just remove this part, this will also give you the same result if you write lower dot tail equals to true. So this part, lower dot tail equals true, is a by default answer. So pnorm q equal to 1.2, mean equal to 0, st equal to 1, and lower dot tail equals to true. Now, if you hit run, this will give you the proportion. So the proportion is 0.8849. Now, suppose I have, what is the probability for the second problem? Let me choose this. Find the proportion or the probability that z is greater than 2.42. What is the difference between number 1 and number 2? In number 1, we had z less than, and in number 2, we have greater than. So most of the things should remain same. The only things that should change are the values of the q and lower dot tail. So for completing number 2, we should again use the same function, that is pnorm. The q is changed over it, so the q value is 2.42. Mean is equal to 0 because we are still working or with the z, that is standard normal. That so mean should be equal to 0, st should be equal to 1, and over here, since this is a greater than, so we should have lower dot tail, this is equals to false. That is, it is not finding the value in the lower tail, it is finding the value in the upper tail. So greater than implies finding values in the upper tail. So pnorm q equal to 2.42, mean equal to 0, st1, and lower dot tail, this is equal to false. Now, if we hit run, we get this value to be 0.0076. Now, what about if you want to find some function, some probability in between? That is, we want to find probability that z is in between 1.35 and 2.42, or let me 2.45. Let me give a different number. How can we find this? Probability of z is in between, that is greater than 1.35 and 2.45. Since 2.45 is 45 is higher than 1.35, so first we need to find the probability of 2.45 less than, that is the lower tail equals to true, and from that we should subtract z of less than 1.35. So to do this in art, we can do pnorm q is equal to 2.45, mean equal to 0, st equal to 1. Now I am finding the less than type, so I am omitting the lower dot tail equals to 2 function because that is by default. To that, I will subtract the lowest value, that is a lower bound that has been given to us, that is 1.35. So to do that, we have pnorm q equal to 1.35, mean equal to 0, st equal to 1. And if I hit enter, I get the in-between probability. That is, the probability of the z lies between 1.35 and between 2.45. Now, if the z-score is given to us, how can we find the proportion? So far we were discussing, we're finding proportion given the z-score. Next, we have to find z-score given the proportion value. The proportion is given to us, we have to find the z-score. For the first case, in this case, let us find the 95th percentile. How can we find the 95th percentile over here? Now, to find the 95th percentile, over here, we will be using the quantile function. That is, instead of using pnorm in the first few examples, we will use the quartile norm, that is qnorm function. And over here, the proportion value that is given to us is 0.95. So we will write p equal to 0.95. And again, as it is, that is mean is equal to 0 and st, this is equal to 1. Again, if you can write lower dot tail equals to true, or you can simply omit that because that is by default. And if you hit enter, it gives the value of the 95th percentile. So that is 1.645. Now, how about finding the z-score separating the bottom 2.5 percentage and the top 2.5 percentage? So let me do this step by step. So find the z-score separating the bottom 2.5 percentage. So bottom 2.5 percentage means I'm going from the left to the right. So going from the left to the right, this implies I still have to use a lower dot tail equals to true option. So over here, once again, we have this q norm. The quartile that is, sorry, the probability is given to us, or the is 0.025, because 2.5 percentage, if I do that in decimal, it is 0.025. And we have mean equals to 0 and st, this is equal to 1. So this gives the value to be negative 1.96. Now we have the same kind of problem, but little different over here. So number 3, it says find the probability that the z-score, find the z-score separating the upper 2.5 percentage. How can we do this part? So whenever looking for the upper 2.5 percentage, this implies we are looking from the right. So if we're looking for the proportion from the right, then we should have that lower dot tail option to be false. So to solve this, we have the same thing just like number 2. So we should have q norm p equals to 0.025, mean is still equal to 0, st equal to 1, and over here we have lower dot tail, this should be equals to false. Now, before even finding the answer, what should we expect? So we should expect that whatever we obtain in number 2, number 3, the answer should exactly be the same, but the sign should change. So instead of having negative 1.96, we should get the value to be positive of 1.96. So let's check if it is correct or not. See, we have exactly the same thing that I discussed. So this is negative 1.96, and if we are looking for the upper tail, then it is 1.96. Because standard normal distribution is symmetric, So the bottom 2.5 percentage and the top 2.5 percentage both will give you the same value of your z-score. One in negative, another one in positive. So this is what we can do with a standard normal distribution. Now let us discuss about non-standard normal distribution. Now we have non-standard normal distribution. For the time being, let us assume, so whatever we will do in this section, let us assume that the variable x, this follows a normal distribution. Since this is not standard normal, it will have a mean different from 0 and a standard deviation different from 1. So we have the mean, this is equal to 3420, and the standard deviation, this is equals to 495 grams. So this is our non-standard normal distribution. So based on this, let us find the first problem, that is first proportion. So we will be finding the probability that x is greater than 4320. How can we find? So for the now in this case, we will be finding the proportion. So we are finding the proportion in this case. So for the first example, we have to find the proportion of x greater than 4320. How to find this? Now to find this, we can again use the same formula as we were using for the standard normal distribution. So we will be using pnorm. Pnorm implies we are finding probability. That's why we are using pnorm. Pnorm, what is Q? What is the quantile we are looking for? That is the value that we're looking for. Over here, the value of Q is 4320. Now, what is the mean of this? Now, we are no longer working with standard normal, so the mean is not 0. In this case, the mean is what we have assumed. That is, the mean is 3420. That is given over here. The mean is 3420, and the standard deviation is 495. Now, what is the sign we have? X is greater than 4320. Since again over we have a greater than sign, so we should have lower dot tail. This should be equals to false. And if we hit run, we have 0.345 percentage. Now, what about if we have probability that x is less than 2400? To find this, again, we can use the same formula. The pnorm Q is equals to, now the value of Q has changed, that is 2400. Mean for this example is 3420, and the standard deviation is 495. For this example, the lower dot tail equals to true because we have a less than sign. Since it is a default value, I'm not writing that. So if we hit enter, we get this proportion value, that is 0.0196. Now, similar to the standard normal distribution, we can also find the values of the given percentile is given. We can find the values as well. So percentiles are given. We can find the values. We can find the corresponding values. So suppose, for example, I want to find value of x which corresponds to 40th percentile. To solve this, we can again use the qnorm function. So qnorm always gives us the quartile. Qnorm, we are looking for this probability of this proportion. The proportion which is given to us is 0.40. Qnorm p equal to 0.40, as again we have the mean. For this part it is 3420, and the standard deviation is 495. So So the value of x corresponding to the 40th percentile is 3294.59. Similarly, if I want to find for the 90th percentile instead of the 40th percentile, if I want to find for the 90th percentile, I just need to change the value of q norm p equal to 0.90. The mean remains the same and the standard deviation remains the same for this particular example. So this will give me the value to be 4054.368. So this is what we have for the normal distribution. So we discussed about the standard normal distribution and the non-standard normal distribution. Next, we will find the t-score, finding t-score. To find t-score, we need two things. First, we need the proportion of the probability. Second, we need to find the degrees of freedom. So just like the standard normal or the normal, we will be finding the t-score corresponding to the 5th percentile and the degrees of freedom, this is equal to 15. Now you must be aware that degrees of freedom is nothing but the sample size minus 1, that is n minus 1. So for this case, to find the t-score corresponding to the 5th percentile, we have to use the probability, the function, that is qt, and we have the value of your proportion of the p. This is equal to 0.05, and we have the degrees of freedom. The degrees of freedom, this is equal to 15, and lower dot tail, this is equals to false. Sorry, this is equal to true because we are looking for the 5th percentile. So if you are looking for percentile, we should have as it is. We should just write the 5th percentile, that is 0.05, and the degrees of freedom. Let me give another example. We need to find the t-score corresponding to 13th percentile and sample size equal to 21. To do this, first we have to calculate the degrees of freedom. What is degrees of freedom? Degrees of freedom is equal to n minus 1. So for this case, we should have the degrees of freedom should be d of f, for this case should be 21 minus 1. So this should be equal to 20. So once we know this degrees of freedom equal to 20, now we can enter that in the codes. So again, we have q of t. The value of p over here is 0.13 because we are looking for the 13th percentile. Now degrees of freedom over here is 20. This is always 1 minus the sample size. So sample size is 21. So the degrees of freedom is 20. So this gives us the value corresponding to the 13th percentile. Now, if we want to find, the t-score for 98% confidence level and degrees of freedom, this is equal to 40. How can we do this? So over here, we are finding the t-score for 98% confidence level and degrees of freedom equal to 40. There's a difference between what we did in, suppose this is number 1, number 2, and this is number 3. So there's a difference between what we did in number 1 and number 3, or number 2 and number 3. In number 1, we are looking at the percentile. In number 3, we're looking for the confidence level. So for this case, to find the t-score, we will use the same function as it is, q of t, but over here we need to change the p a little bit. So p, this should be equal to, since we're looking for 98% confidence, so this should be equal to 1 minus whatever we're looking for, that is 0.02, and this should be also divided by 2, because we are looking for both sides. So we should actually get the values for both sides. We should get 2. Basically, in this case, we should actually get 2 t's. One for the lower equal to true, another one for lower equals to false. So let me show this to you, because it is looking for the confidence level. So actually, we're looking for the values of T1 and T2. So this should be P equal to 0.02, degrees of freedom equals to 40, and in the first instance, we should have lower dot tail equals to true. So this will give me the lower bound. So this gives the value to be negative 2.42. And for the upper bound, we should also have the same thing, but instead over here, we should have the lower dot tail equals to f. So again, both will give you the same answer, but with a change of sign. One with the lower has a negative value, one with the upper has a positive value. So this will give me the lower t value. The second one will give me an upper t value. People always say this to be T1. So we can also say this to be a value of your T1. And the second one to be your T2. So you can find it in this way. Now we can also find the proportion. So if we are finding the z-score, so we can also do is find proportion given t-score. So for example, I want to find proportion of t is greater than 2.704, and we need to know the degrees of freedom. The degrees of freedom is equal to 45. To solve for this, we can again use the formula of P of t. So this, since we are finding proportion, we are not using QT. Q is for quantile, P is for probability or proportion. So P of t, now we have the quantile value, that is Q is equal to 2.704. And we can, and only thing that is left to do is finding the degrees of freedom, that is degrees of freedom equal to 45. Now once again, since it's greater than, so we will have lower dot tail, this should be equals to false. Sorry, I pressed Control F by mistake. So this should be lower dot tail equals to false. So this gives me the probability that the t is greater than 2.704. So in this way, we can find the probability for normal, standard normal, finding the t-score and finding the proportion from a given t-score. Next, we'll discuss about a QQ plot. So QQ plot or a quantile plot helps us to discuss or helps us discover whether a data set or even a variable is normally distributed or not. To do this, let us find out a data set. So R has some inbuilt data sets. Let me load a data set called tooth growth. So let me load this data set called as tooth growth, and let me check if that has loaded properly or not. So I have head tooth growth. So it seems like it has loaded properly, and it has 3 columns. First one is the length of the teeth. Second one is the SUPP, that is the supplements that were given. The third one is the specific dosages. So by using the head, I can see how many columns are there. The another way to check how many rows and how many columns are in a given data set, the dim function or the dimension. This gives you the dimension of a data set. So the dimension of this data set, let me check that. So dim tooth growth, this shows that there are 60 observations and there are 3 columns. So the dim function gives the dimensions of the data set. Now, let me check whether this variable length is normally distributed or not. To do this, let me use the function QQ norm. So we have QQ norm, and I'm interested in the length variable of the truth growth data set. So QQ norm truth growth dollar length. So if I hit enter, it gives me a normal QQ plot. So we have this kind of scattered plots, right? Some scattered bubbles over here. But how do we know that this falls on a straight line? To do that, we can also add another statement. That is, we can use QQ line, but this should be done after we do the QQ norm. So this should be QQ line, and again the same variable that we need to choose. That is truth growth dollar length. If we hit enter, this superimposes on the previous graph that we had. And if I zoom this out, seems like I have already one plot zoomed in. So if I just zoom this, you can see that this is a straight line, this 45-degree line that passes through. And there are a lot of points which is scattered and not falling on the straight line, especially at the ends. So we can clearly say that the length variable is not normally distributed. So using this QQ plot, we can find if a given variable is normally distributed or not. Okay, so that's all what I have for today. Thank you.